So welcome everyone to the April seminar. We have Guanyi Zhang presenting today, which was Better Time for College. It's the same paper, just the title is now Better Late Than Never. So it's 1 hour, Guanyi, including questions. So I assume you're okay if people want to interrupt during the presentation. And then hopefully we'll leave a few minutes, maybe 10 minutes at the end for final question answer sessions. So so you know, it's being recorded. The recording will be available on the GL website early next week at the latest. Everybody else, other than obviously the speaker, could you mute your microphones, please, while Guanyi is presenting, and then if you have any questions, of course, unmute and ask the question. So over to you, Guanyi.
Thank you. Let me start sharing my slides. Okay. Thank you all for having me here and for tuning in at this time of the day and the season. So I'm really looking forward to hearing your comments and questions. It's really a different paper compared to the one I was originally planning to present. So it's rather new results. So I appreciate any comments you have. So the paper title is Better Late Than Never, Aggregate Impact of Intermittent College Enrollment and Tuition Subsidies. So, and also please do interrupt me if you have questions, just because when I'm sharing screen, I can't really see anyone from the audience. So a little bit of motivation and backgrounds. So we do see that in the United States, we've experienced persistent labor productivity slowdown in the last decade and more. At the same time, the gaining of college access has also slowed since 2000. In fact, we're predicting that the U.S. college enrollment is going to persistently decrease between the next couple of years. And for all the college that administrators, that's one thing that they're worried a lot, is that the college enrollment has been consistently falling for the last 8 years. So that brings us the important policy background is policy motivation, in the sense that we should consider what kind of policies could incentivize college enrollment. And according to a lot of research, college policies not only increases college enrollment, but also should have important distributional and growth aggregate impacts too. So what our existing understanding in terms of policies that focusing on incentivizing college tend to focus on early college, not early, but regular, our standard college enrollment, in the sense that students graduate from high school, they go to college. And in all of these policies, if I can categorize them, focus on increasing access to student loan programs, give students grants, scholarship, or provide better information of college and all these things. So, but however, when I look at the college education profile over the life cycle in the United States, so these are data from the National Longitudinal Survey of Youth, 1979. It turns out that a big chunk, in fact, most of the students, college enrollees or people with college experience in the United States, doesn't actually just concentrate between age 18 to 22. Majority of them go to college at much later age. So among the entire population of the United States, about 9% of the students completed college by age 22. That's what we call a traditional college student, go to college right after high school. And all of the students with bachelor's degrees in the US, about 10% of them complete college at much later age, after age 35. So as you show in the two figures here, the left one, panel A, is the college enrollment. So if I'm attending at least 5 months out of a year in college, in accredited college, of course, the peak is right after high school, but it tapers down, but still have a significant share at a much later age. And the right graph is the BA. What age do people receive their bachelor's degree? Again, the big chunk of increase is around age 25, and still goes up at a much later age. So that goes to why this is the case, right? So in addition to people enrolling in college at a later age, I observed that there's constant in and out between college and work. So you go to school, college, and then stop out for some periods and then come back to school. So I call this repeated school work, school transition as intermittent college education. So using the NLSY data, on average, about 1.7 times, people experiences spells of churning about 1.7 times. And this is different from what I call the canonical or traditional life cycle human capital acquisition style, where you finish all your school before you go to work. So then that gets me to the question for this paper. So what's the value of going to college if I'm coming back at a later age or enroll at a later age? And what are the aggregate consequences of encouraging this kind of later age enrollment?
Can I ask how you treat people who keep going to school part-time? Like I was working and going to school at the same time for years.
Yes. So for the data that I'm taking, so as long as people go to a school, attend a school for 5 months out of a year, they're considered
even part-time.
Either part-time or full-time. Yes. Yeah. Yeah. In fact, that's actually extremely important margin for
yeah.
Yeah.
So you can differentiate that.
Yes. Yeah.
Okay. Yeah.
So in other words, if I'm going to school full-time, say it's a 4-year program, I finish in 4 years. But if I'm going to school part-time, maximum I can go for 8 years in a simplified way of saying. So double it. So a brief preview of the results for this paper. So one, I find that flexible access, in other words, allowing people to go to school at any time they want and come back and out, in and out, contributes to about 3/4 of the total welfare value of college. And then college serves as an investment for the younger people and then a risk reduction for the older people. I look at a variety of policies that trying to encourage the college attendance and college completion. Turns out that, interestingly, student loan programs doesn't change much. However, policies targeting directly reducing the direct costs of college largely increase college access and completion. And in terms of the aggregate economy, it creates a huge labor productivity improvement without really much aggregate cost. And I look at that in a general equilibrium setting. So I'm looking at who pays the cost, either government by the tax revenue or company pays for it through the profit. So to answer this question, to conduct this research, it's really using a theoretical framework. So I construct the overlapping generations model within complete market where there's uninsurable risk to human capital accumulation over the life cycle. So that's really the source of the life cycle uncertainty. And then I want to not focus too much on the borrowing constraints because most of the research, at least in the macro labor literature, talking about education access, focus on the borrowing. So is it because people don't have access to short-term credit, they're not going to school right away? So here I want to say, conduct the benchmark experiment in the sense that I want to give people as much borrowing as possible, so natural borrowing limit. And then the decision making is age by age. So every age I'm choosing whether I'm going to school or full-time or going to school part-time and part-time working, or just stay at home, not working at all, or just going to work. The 4 sort of a parsimonious decisions to keep the model tractable and parsimonious. And then I do have a representative firm that hires workers and they maximize profit and have a government balanced budget to allocate this all of this tax and all these policies. So a little bit more details of the model. So individual humans in my model are heterogeneous. So they're different based on age, their initial entry level human capital and wealth. And once they enter the model, So because of their decision making, human capital changes, their wealth changes, age, education level, work status, consumption income all changes. So I'm trying to have used this kind of ex ante heterogeneity, the state variables of the model to simulate basically the entire space of US workers. So because of people are different and this is general equilibrium model, I need to keep track of the aggregate state variables so that I can generate flexible or I guess the wage and interest rate and all the prices will change based on individual decisions in the general equilibrium. So individuals are making decisions, as I mentioned earlier, whether it's working or part-time school, part-time work, full-time school, full-time employment. So they optimize whichever is the best is what they're choosing in each given period of the time. So I'll go through the model rather briefly because I think most of the model is rather standard. So this is an example if a person is full-time working. So the person's value function at this age is to forward-looking their entire life cycle value. So they have the current utility coming from consumption, and then this utility term of working, and discount future value. And then their budget constraint comes from their source of the cash on hand is their from wealth plus interest returns from their wealth. This is their labor income post-tax. So wage rate multiply how much human capital they have. So I assume if a person is working, they're full-time working. So I don't have like hour differences. And then plus some lump sum government transfer of the budget. Then they can use their money to spend on consumption or saving for future. So their human capital edge is human capital accumulates on the work too. So if you're working, so your human capital just increased by lump sum A. So it's to show that there's a learning on the job. And then little a here is a curvature of human capital accumulation. And it's subject to this epsilon. Epsilon is the labor market shock, the human capital shock. So every period you have a shock, that changes your human capital in the future, and then which reflects your future wage. So there's perturbation. This labor market risk is built in a rather simplified way here to enter the model. And S is the savings. So savings, everybody can borrow up to the natural debt limit of the economy of the person. So natural debt limit in the sense that I can guarantee that using I can pay it back before I leave the world. So this is the value function for alternatively if a person choosing to go to school full-time. Similarly, they maximize utility from current and they expect future value. So the difference is that in addition to consumption utility, the person have what I call a psychic cost or maybe a psychic gain of going to school. So it can be positive or negative. So for some individuals, this utility term can be negative, just hate going to school. Going to school is very painful. For others, going to school may be very happy. I just enjoy going to school. So this parameter is, I don't give a term for it. It's just age by age calibrated to match the education profile, which I'll show you in a couple of slides. Education patterns of the individuals in my sample. So in particular, I'm targeting, so that's what I'm showing. I'll show it later in the calibration slides. So it's a rather important term that helps my model to generate the moments that matches the education decisions. So in terms of budget constraint, of course, if I'm going to school full-time, I can't really work. So there's no labor income. The difference is that you not only have no labor income, you'll have to pay a cap of direct tuition cost or schooling related cost. Then a big benefit of going to school is that your human capital increased by this lump sum delta each year. So I differentiate the returns to school by how many years of education people have. So if you're first-year students to third-year students in the US, mostly traditionally 4 years. So before your last year of gaining the degree, so it's delta. But then the last year, I differentiate it by how many years of schooling you already have, because of all the micro literature showing that the sheepskin effect of college education. So your last year, you finish your degree, you'll have a much higher labor market return compared to, let's say, a college stopouts or dropouts. So that's that. So then similarly, if this person is part-time working on part-time school, it's just a composite of the two value functions and how they look like, as I showed before. And then if the person is full-time stay at home, they just don't receive any labor income, and then their human capital depreciates by every year of not working or learning. And retired individuals receive retirement social security benefit. So that's that. And then in a stationary general equilibrium, all individuals optimize their own problems and market clear and social security budget balance and government balance budget. So calibration, so these are a few parameters I mentioned and how I calibrate them. So this utility parameter calibrates to the US employment to population ratio. The parameter that governs the curvature of human capital accumulation, calibrates to the wage spread, the volatility of the variance of wage from age 18 all the way to age 65. Learning on the job, how much and how soon I learn, calibrates lifetime wage growth rate, average. And then these are the two parameters for learning through school. So Delta 1 is before the person receives a bachelor's degree. Delta 2 is the last year of schooling before they reach a bachelor's degree. Human capital depreciation calibrates to the average unemployed annual wage loss. College cost calibrates to the college spending share, aggregate college spending share out of the US GDP. So the other parameters are rather standard, I suppose, for a macro model. So one key set of parameters are important is that the initial conditions. At age 18, people entering the model. So the state variable, human capital and wealth, how do I generate that? So rather than assuming from the literature, people usually assume bivariate normal distribution and then calibrate the means and the volatilities of that distribution to match a life cycle earnings profile. Rather than doing that assumption, I directly take the data from the NLSY survey. So for human capital, I use the AFQT test scores. And then for wealth, NLSY doesn't exactly have a family wealth variable, but what I use is their 3 years, the first 3 years between age 16, 17, 18, 16, 17, 18, the average of the family wealth. So as an approximation, family income as approximation of the wealth level of a person. And then I rank them from the bottom to the highest and then categorize into, in fact, 20 bins. And then, and then I directly take the distribution of individuals among these 20 by 20 bins into the model as their starting initial human capital. It's rather important because, as you can see from this much more like a 5 by 5 distribution matrix, is that the family wealth and human capital conditions are especially family wealth is extremely skewed. So if I assume by very normal distribution, it removes the skewness, and these initial conditions are important to generate later decisions. So no matter how I calibrate the mean and the variance and covariance, if I assume a bivariate normal distribution, that will essentially skew the rest of the results. So another set of targeted moments, as I was saying earlier, this utility parameter of schooling. So I calibrate those set of parameters age by age. So so I have one value targeting each age, whether they are continuously enrolled or whether they're newly enrolled in school. So it continuously enrolled means that I was in school last year, I'm continuing to be in school this year, whether full-time or part-time. New enrollment, I was not either working or stay at home, and then I newly entered the school. So these, and then lastly, whether when do I finish the bachelor's degree? So these are targeted moments. So I suppose they match the simulated data, match the actual data almost perfectly. So the target really come from this utility parameter. So a set of untargeted moments to check. There are quite a few more, but here, just for the sake of simplicity, I want to show you really just two figures, two panels. One is the BA completion age. So among the all with bachelor's degree, what's the percent of the people finish bachelor's degree by age 25, age 25 to 30, and then by the age bins. So the blue is data, the red is model simulated. I think it targets pretty well. And then the interruption patterns. So among the population, so how many of people, traditional students, finish bachelor's degree by age 22? How many of them finish bachelor's degree older than age 22? How many of them are just only college dropouts, only finish some years of college before they got their degree, and that's it for the rest of the sample? I can see their life. And also what's the percent of people never complete or never attend college at all? So I would say these are not targeted moments, but my model generated rather comparable this intermittent college education profile compared to the data. So move on to the results of this project. So first, I want to show you a little bit of the aggregate results. So baseline is the baseline model I just described. So column 2, I removed the flexible access to college. So what that meant is that, so in this experiment, the individual can, if they want to go to college, they can only go to college right away. So my model starts at age 18. So age 18 is your chance of going to college. If you don't go, you can't attend college anymore. And once you attend college, you either have to finish it all, or if once you decide to leave college, then again, there's no chance to come back. So as our traditional assumption that people can only go to college at once. And then the column 3 is that I remove college completely. So there's no college access in the model, and then calculate the general equilibrium. So obviously, if I remove flexible access to if I remove college completely, there's nobody attending college. And if I remove flexible access to college, the bachelor's degree attainment dropped by 28%. Another key value that I calculate is the welfare value, which is a rather important measurement for the rest of this paper or this talk, is consumption equivalence. So what I'm measuring here is that if, say, column 2, I remove flexible access to college, how much do I have to compensate the baseline people to be able to equally happy in terms of consumption, to be equally happy? So I call that as a welfare value of college, because the reason I look at the welfare value rather than a lot of the literature just look at the financial returns is because, one, college not only have financial returns, but also a utility value compared to other choices. So I would assume that's a rather, and obviously the welfare value, the utility welfare value determines the decision making. Well, obviously, college has a huge welfare value compared to, well, a huge welfare value so I have to compensate by almost 29% of the baseline consumption to make them equally happy. And then the welfare value of flexible access to college at each age of their working life, 21%. That's almost about three quarters of the total welfare value. So this conclusion directly tells me that college has a huge aggregate welfare value to individuals. So look at it more.
Can I ask another question?
Yes.
I really, I mean, I don't have any, I guess, evidence at this point, but I really feel this has to be very different by gender. Is all of your analysis pooled? I think the flexibility is of much greater value to women.
Yes, sure that there definitely has to be much more refined gender heterogeneity there. So the data came from a pool, both male and female in my sample, both men and
Oh,
women
so
in my
you
sample.
can't tell?
Technically speaking, I could, but my model didn't differentiate men versus women. The only reason I don't differentiate men and women is because there's already quite a number of state variables to keep track of. So the computation is getting a little intense. So that's why I don't differentiate. But that's a really good question. So there's a paper by Maria Cristina Denardi and her co-author published in Journal of House. I forgot which journal it was. Anyway, so he was talking about that's essentially the second best. Ideally speaking, we could keep track of gender in the overlapping generations model. Will generate much better aggregate targets. But given sometimes these models get computationally too burdensome, their second best is that you really have to just pull both men and women in the sample and be a little agnostic, but it creates a second best to the model. But
Okay.
yeah, thank you. Yeah, so continue to the heterogeneous welfare value of college. So following the experiment, no flexible college or no college at all. So I'm looking at the welfare value, this consumption equivalence age by age or by age group. So the gray bar is the how much I have to compensate people if I remove college at all. So obviously, traditionally, most people attend school at a younger age. So they have a large welfare cost of if I remove college from them. And then flexible college, later older people take advantage of it much more. So that means more for people older than age 25. So I want to further continue explore some theoretical underpinnings of why people go to college at a later age compared to, again, the traditional thoughts or the canonical thoughts that people finish high school, go to college, either finish it or not, and then that's it. So I look at it again by removing the access to college age by age. So previous exercise was just completely remove flexible access to everyone. So here I'm removing access. So if you're age 64, you don't have access. The comparison is benchmark baseline model to the alternative of I don't have access to college at age 64. So if I'm at age 59, the comparison is I don't have access to college from age 59 onwards to the rest of the working age, 65. So I compare this age by age welfare, the consumption equivalence to draw the conclusion. So total gross value, gross welfare value seems to me that at a young age, of course, starting age, the consumption equivalence is the highest, almost 30%. However, this total welfare value persists through, and rather consistently through the rest of a person's working age in terms of having their access to college. So then I was thinking of what's the, really from the traditional literature, what's the actual value of going to college? Again, coming from the human capital investment. So college is an investment device for a person to gain higher human capital. So what I did here is that, so I compare a model, so I removed, so because I do have a human capital risk in my model, volatility of human capital in a model. So this exogenous shock perturbs the human capital. But if I compare the original seminal literature that initiated this human capital investment literature, I really is looking at a static environment where there's no risk. So I'm assuming that the investment is just purely gaining my human capital. So I remove the risk of the model and just to look at how much this investment returns increases my lifetime value and compare that with the counterfactual of whether I have access to college at each year. So it turns out that the pure investment, the purpose of gaining human capital is the highest, again, for a younger age, but it essentially entirely disappeared after age 23, 24. So then what's the rest of this value? this welfare value of college. So then what I removed from that comparison is the risk, the labor market risk. So then I start to do another exercise to look at people's perception of risk. So I compare a model with risk and a model without risk, and then compare to measure the risk perception, the welfare value, welfare cost of risk over the life cycle. Then compare the same set of value by having access to college at each age. So it turns out that my welfare cost is higher for people without college at each age. So it is what I show in this graph. So my risk cost is about 28 to 30% higher for people without access to college than those have access to college from age 29 and onwards. And then the risk perception is even the highest for people around 23, 24, and it's much lower for younger people. So the shape of this risk reduction, so in other words, having access to college reduces the welfare cost of life cycle labor market risk. So the shape of this graph kind of matches with the gap between the total welfare value and then the investment value. So that gives me draw the conclusions that another major reason that people go to college at a later age is because it reduces, college allows people to reduce the labor market risk. Intuitively speaking, if a person receives, let's say, several years of consecutively or some severe negative human capital shock, so what they can do is that they can go back to college and retool themselves and then move back to what they want them to be in the trajectory. So this together, this investment value and risk reduction value forms my understanding of why people go to college at different age. So younger age people go to school for their human capital investment value. Non-traditional older age people go to school because it reduces the welfare cost of risk. So I want to compare what I did with again, a whole bunch of literature talking about going to school or delaying college is because whether they have access to credit or loan access. So what I did here is that because I already gave people the maximum possibility to borrow, the natural debt limit, so I can only reduce their access to credit. So my counterfactual is I reduce everybody's borrowing limit by 15%. So the comparison is that the graph is the age by age BA attainment. So the total number of percent of bachelor's degree holders in the economy. So even with 15% reduction of access to credit, it is of course a little bit lower BA completion, but doesn't really change as much. In terms of the aggregate economy, so column 3 is the result for aggregate economy. So there's about 2% reduction of BA attainment, but not so much. Other aggregate indicators doesn't really change much. So I want to say is that for this research, this paper, I find that most of the reaction happens really beyond just this borrowing limit story. It happens for people with a capacity to borrow, but they're still deciding whether to go to school or not. So then with all of this mechanism understanding, I want to conduct some policies, trying to see what kind of policies that we could better incentivize college access and aggregate effects. So given the fixed returns to college, in other words, I'm fixing this experiments, the first set of results in the partial equilibrium standpoint, so the returns to college is the same for everyone. So fixed wage, fixed interest rate, and all that. So in that case, really, when I think about whether I want to incentivize people to take the investment value or risk reduction value, really the policy, the rest of it is to how do I reduce the cost of engaging all these devices. So I set 2 sets of policies. One is public funded, the other is private funded tuition. So coming from a few of the heated debates in the US politics these days. So free tuition for all. So if I remove the college tuition, the kappa value, it becomes 0 for everyone who wants to go to college. Then who pays for college? So it will be paid by the government tax revenue. So everybody then equally share that burden. Then the second policy is loan forgiveness, which was coming from Biden's big thing. So, so for everyone who completed 4 years of college, I calculate how much a debt they have accumulated up to the 4 years of tuition rate by the year after they finish college, finish 4 years of degree, and then I give them a lump sum rebate. So then all of these loans related to college is forgiven. Again, it's coming from the tax revenue. So everyone else shares it, or everyone in the economy shares it. Then the last one is a kind of a creative policy I was thinking, because I do have part-time school, part-time working. So I gave people income tax, individual's income tax exemption if this is a part-time worker. Then the privately funded policies I'm comparing, so I let the private company to pay for the tuition. So the first one is a much lesser aggressive policy. So if I have a worker who is part-timely working, part-time school, the company pays for their tuition, the part-time tuition, perpetually as long as they're working for us. And then the next one is more aggressive. So all marginally attached to workers' tuition. In other words, if they're a part-time worker, they got tuition paid by their company. And if the second year, if it's their first year working full-time and their last year was working for a company, their tuition is paid. So these are the 5 policies, 2 types. So here are the college response between these across these 5 policies. So the first 2 rows are looking at enrollment responses by age groups. So tuition free, so nobody pays tuition, has a huge increase of enrollment response for young people. And then if I look at the BA completion rate, the bottom 2 panels, so the tuition-free policy increases in the partial equilibrium, increase the BA attainment from a young age, shoots up immediately, like really fast to 80-some%. So I guess it's high return. Going to college is high return, and if it's free, cost-free, a lot of people want to go to college. But note that even though it's tuition free, because of the opportunity cost, because of the psychic cost, not everyone take advantage of that. Another rather interesting comparison is the loan forgiveness policy. So notice that the enrollment responses for the loan forgiveness policy, so I have an increase of earlier age college enrollment, but also it lasts to age 30. So still before age 30, there are people respond to it by going to college, which means this loan forgiveness policy somehow not only reduces the early age, allows people incentivized to take the investment value of college, but also provides people to later age people to take advantage of the risk reduction value of college. So I do see a loan forgiveness in terms of college completion rate, rather high incentive there. Then in terms of the company paid policies, so obviously if your company pays for your tuition and all that, so people respond to it. The more aggressive, as I call company pay all marginally attached workers, also incentivize more later age college enrollment too. In terms of the aggregate impacts, so because really individual students are not paying the tuition, but then someone else have to pay for it, whether it's shared by the tax burden or by the company. So then the direct question is it worthwhile to incentivize all these people to go to college? So then to look at aggregate impacts, I look at the general equilibrium. So general equilibrium, because more people are going to school, there's obviously a price changes, then there's a tax and all, and then the profit rebate back to the households changes. So if it's in general equilibrium, because more people are going to school, they accumulate higher human capital. So effectively speaking, we have more effective laborers. So consistently, we tend to see a relatively reduction of wage rates. For the experiment, if there's not so much of a wage rate reduction, there's something else is changing. For example, the lump sum tax income and all that. So in general equilibrium, that cancels out the wage change or the tendency for wage change. So the result is that the BA attainment rate slightly tapered compared to the partial equilibrium, but still the shape maintains rather similarly compared to the baseline. Much more people go back to college, not only go back to college, but also complete their bachelor's degree across these 5 experiments. Then the aggregate, one of the biggest aggregate impact is that the average labor productivity. So all of these policies raises the average labor productivity compared to benchmark. So tuition-free program, about 5%, company paid, aggressive company paid tuition program raises the average labor productivity by almost 6%. Then if I look at all the other aggregate variables, not so much changes compared to the baseline model. So what that tells me is that it's a really good thing to have a policy to encourage college attendance, college completion, and it raises average labor productivity of the country, and also doesn't seem to have much other aggregate costs. So that answers one of the initial motivation of this project, in the sense that education policy is helpful for raising to counter the labor productivity slowdown. So that gives to the end of this project or this presentation as a conclusion. So large number of people in the United States engage in these intermittent spells of college enrollment. They go to college at various age and later age, they're coming in and out. And this kind of flexible access to college contributes to about 3/4 of total welfare value of college. And looking at the reasons, so flexible access means more for older people older than age 24. And it's because college serves as an investment value for the younger people and the risk reduction value for the older people. Policies reducing the direct cost of college raises college access and completion significantly. And in particular, public funded tuition-free programs raises college completion the most. And then the loan forgiveness program raises later age enrollment the most. And then in terms of the aggregate implications to the productivity of the economy, turns out that aggressive company paid tuition program raises the labor productivity the most. So that concludes my presentation.
Okay, thank you, Guanyi. Any questions? Sorry, Jörg. I don't know if I'm pronouncing it correctly.
I was applauding, but I can ask a question. That's fine. I think I find it quite plausible, your result, that for the young it's rather an investment device, and for the older it reduces risk. Now in your setup, I think you just discriminate between college yes or no. But I would expect that older people choose for other types of college education. Now, I'm not an expert for the American system, so I don't really know, but I guess that maybe some more career-oriented college programs, I don't know, professional, vocational, community colleges, cater for these kind of people. So is that something you could look at, because it means that these programs also serve a different function in people's
Right, that's a really, thank you. That's a really good question. So here for this project, I'm considering both community college and 4-year accredited college, similar as college. So community college is a 4-year accredited program, 2-year accredited program in the United States. And so if they only finish community college, to me, it's considered as a college dropout. In fact, the calibration and all that. So if it's community program, it's really included in this project. What I didn't include was let's say career training programs. Let's say the company pay or like a company's on the job trainings or things like that, or some kind of skill trainings. I could potentially compare that too, but again, for the the parsimonious model purpose, I did not in this. So I couldn't exactly answer what would that be. One thing I could potentially infer is that it's comparing, so in terms of the model, it's comparing those who go to school full-time or part-time compared to those people who are not. And then the accumulation of human capital is on the job. So I consider everyone else is learning on the job. So the calibration of working in my model, the learning on the job parameter A is for all of those wage process. So hopefully that accounts for the other means of accumulating human capital, even though I could not exactly pinpoint where it came from. So.
Yeah, just kind of have a follow-up because this is exactly what I was thinking as well, that, for me, in my mind, it was that the underlying assumption here is that college is the only thing that increases productivity. But a number of countries, there is vocational education, which actually might be more beneficial. And so in your policy recommendations, it seems to be like a very, okay, this is US data where maybe in the US college is much more. But generally speaking, it might be that, older people are better off in a vocational, which might increase the productivity. And in some of the European countries, actually, even at the age of 18, you have basically clear-cut kind of paths where you can either go to college or you can go to a vocational kind of school. So that's kind of, I don't want you to answer because I know you can't get it in your model and stuff more specifically, but it's just that the policy based specifically is with the underlying assumption that only college increases productivity is slightly kind of concerning for me.
Right.
But yeah, we can talk later. I want Klaus to give other people the chance to ask questions. Klaus?
Yes, thanks. So maybe I'm not fully getting the model, but what is about innovations? Let's assume college attendance has an effect on innovations. Well, in your model, does this just go into productivity, or otherwise, if college attendance creates innovations, the positive effects might be even higher?
It could be, yes. For this model, it's for the current model setting, it's a stationary equilibrium. In other words, I do not have aggregate productivity shock. So if I'm building in, which could be a really, thank you for this comment, could be a really interesting experiment for me to experiment on. So what you're saying is that more people, whether I'm building an endogenous aggregate productivity change, TFP shock, or just introduce a aggregate TFP shock. So that could, so what that meant is that, in fact, because then that will translate to even higher returns to college. So that will induce even higher college responses, even larger welfare. So that's a really good comment. So I guess for the result I have, it could be a more conservative, say there's no aggregate productivity change. What happens to the economy? Okay, thanks.
I wonder how Bill Gates falls into this kind of thing. He didn't finish college, but anyway, any other questions? Okay, in that case, thank you very much, Guanyi, for an interesting talk. Good time to finish as well. And yeah, thanks. That's great presentation. And we